Hi everyone, let's discuss.
So for the question ones, we can do this day. There are four nuts inside the circuit, and the question is we need to find out the Ix and VR2. So the first day we can use the number to simplify first, so easy for us to look. So the first is we put the first is at the. So the question is we need to find out the Ix and VR2. So we can put the numbers 1, 2, 3, 4, and then 1 is equal to I1, and 2 is equal to I2, and 3 is I3, and 4 is I4. So easy for us to find out the answer. Then we can put IR1 is equal to, we can see that IR1 is equal to I1 minus I2. It was because the I2 is supply the power, so it's negative. Then we can find out the IR2 is equal to I2 minus I4. It was because I4 is supply the power, so it's minus. And we can notice that IR3 is equal to I4. Then we can find out the IR4 is equal to I2 minus I3. And IR6 is equal to negative I2. IV1 is equal to negative I4, and then IX1 is equal to I1. That means it's equal to 2A. IX2 is equal to negative I3, so that means it's equal to 4A. I3 equal to negative 4A. It was because supply. We need to solve the KVL at node 2, mean the I2. So we can see the negative R1 plus R2 plus R4 is equal to 0. Why we need to, with the formula V equal to IR, we need to find out V. So the R, the I, and R need multiply. So IR negative R1 multiply IR1 plus R2 multiply IR2 plus R4 multiply IR4 is equal to 0. Then we can see that the IR1 is equal to I1 negative I2, just as the first we find out, and R2 is multiply I2 negative I4 and plus R4 is multiply I2 plus I3 equal to 0. So that we can find out the negative 4I, 1 negative 4I2 plus 2I2 minus 2I4 plus I2 minus I3 equal to 0. So then we need to find out the KVL of loop 4, and it was R3 minus 4V minus R2 equal to 0. We can see that we can use the formula V equal to IR. So the R3 multiply IR3 minus 4V, because it was already forwarded to us, 4V minus R2 multiply I2 minus I4 is equal to 0. And then we can put in the number 2I4 minus 4V minus 2I2 plus 2I4 is equal to 0. 4I4 minus 2I2 is equal to 4V. And then, so now we can find out the value of I2 and I4. So we can use the equation we get at loop 2 and loop 4. So we can get 4I4 negative 2I2 equal to 4V. So the second equation we can get is negative 2i4 plus 7i2 is equal to 4v. So we can use the method of elimination. So we can let i4 is equal to the same value. So we can multiply by 2. So we can write again. So the first equation is still same. 4i4 negative 2i2 is equal to 4. So the second equation we already multiplied. So we can get the negative 4i4 plus 14i2 equal to 8v. So we can use plus minus. So the first 4i4 is already equal to 0. So we can find out the i2. So negative 2i2 plus 14i4, 14i2 is equal to 12v. So we can get the i2 is equal to 1a and the i4 is equal to 1.5a. So that the last we can find out the ix equal to negative i1 plus i2. We can put in the number. So we can get is equal to negative 2 plus 1. So the answer for ix is equal to negative 1a. And we need to find out the VR2. We need to find out VR2 before we need to find out the IR2. So it's equal to negative I4 plus I2. So we can put in the number. So the first we can put in the negative 1.5a plus 1a. So we can get the answer is negative 0.5a. So now we can find the VR2. So V equal to IR. So the R2 multiply IR2. 2 equal to 2 ohms multiply negative 0.5a. So it is equal to negative 1V.
Okay, for example 2, in this figure we have 3 voltage sources and 6 nodes in the circuit. So we need to find voltage 1 and voltage 2. The direction this circuit is arbitrary direction, mean we can choose any direction and still get the same answer. So the first step, find voltage node voltage 1. Write the KCL equation first. So the equation is current resistance 1 plus current resistance 3 minus current resistance 2 minus current resistance 4 equal to 0. Then convert this KCL equation to node voltage equation that combine of Ohm's law and node voltage. So we get voltage S1 minus voltage 1 over resistance 1 plus voltage S2 minus voltage 1 over resistance 3 equal to voltage 1 over resistance 2 plus voltage 1 minus voltage 2 over resistance 4. And then insert the value. Finish this node voltage equation to get the voltage. So after insert the value, calculate the math calculation, we get first equation that consists voltage 1 and voltage 2, but still not complete. And then go to KCL equation to find node voltage 2. So the KCL equation, current resistance 4 plus current resistance 5 plus current resistance 7 minus current resistance 6 equal to 0. And then convert KCL equation again to node voltage equation. And then insert the value, finish the math calculation and get the second equation. So we can submit the second equation into first equation to get the value of voltage 1 and voltage 2. So we get the final answer.